So for this example, say we have 1/11. I say one thing, I'm going to use the back side of it. I say one thing and my hand wrote the other. Example 8. 1/11 x. So you have the x right there next to your fraction. And then we have a positive 1/3 equals 2/5. Then we have a negative 10/11 x. This marker smells bad, y'all. And then add to that 2/5. Okay. So this is similar to the fraction problem that we had done and this problem that we had done. This takes what we learned previously and then just kind of complicates it and puts it into an actual equation. And then here, we've already done a problem that had fractions, but you notice how it was just kind of like one step. This one, it's like, hey, okay, let's take it up a little bit of a notch. And instead of it just being one step with fractions, let's make it multiple steps with fractions. Okay, so the goal is still the same. Okay, I need to know what I can do to get just one single x on one side of the equal sign. And I always look to see what's going on around it. Your first instinct should be like, can anything be added to each other, be subtracted from each other? Is there anything alike? Let me solve that first. And like, that'll already simplify it a lot. And then you might just have like 1 or 2 steps left. So very similar to what we had done in problem 7. Okay. So let me see here. I've got 2 terms on the left-hand side, right? And if I look at those, this one has a variable. This one does not have a variable. They are not like terms. We can't do anything here at all, right? Now let me look on the right-hand side. I've got a fraction. I've got a fraction with a variable. I've got a fraction. These are like terms, right? Both of those can be combined together. So I actually want to combine them together. And I know sometimes with equations, it could really get kind of annoying just because, just like the rewriting, you know what I mean? It's real redundant to just kind of keep writing the same thing over and over again, but it is a lot easier to not mess up if you do so. I'm going to rewrite this. I'm going to perform this at the end, but first I have not done anything mathematically to my left-hand side. So I wrote my left-hand side and I stopped at my equal sign. And now if you look at 2/5 and then plus 2/5, same denominator. So we would add the top and we would keep the bottom. So that becomes 4/5. And then this right here, I haven't done anything with that. So it needs to come down. A little bit better, right? I mean, I started with 2 x's and I still have 2 x's, but I kind of got rid of one term by like being the same type of term and it being common so that I could combine these two. Now let me look. Left-hand side, I have variable, no variable, no variable, variable. So something needs to move. An x needs to move somewhere and a fraction needs to move to the other side. If I do, say I do this one. Say this one's positive, I subtract it, and I come over here and I subtract it. Do you see how I end up getting a negative like term, right? So it's like, I don't want that because that's attached to my x, and I don't want a negative x. But say I look at this one, because it's a fraction, this is a larger number, but this negative sign means it's actually smaller than this one. So what I would do is the inverse, which would be what? Same exact fraction with the same exact variable, but a different sign. I'm going to scoot up, y'all. And whatever you do to one side, you have to do to the other. I would, because this is the term that has the variable, I would be sure to write this underneath this term that has the variable. That way it doesn't confuse you and you think you're adding it to this 1/3, because then you can do a whole bunch of math and they don't even have a variable in common, so you can't. So I'm adding 10/11 x here, and I'm going to add 10/11 x here. Because whatever you do to one side, you have to do to the other. Now, y'all, these denominators are the same, right? I love it when they're the same because I can keep, and then I just perform the action, whatever operation in the numerators. So when this is 3.1, 3.2, 3.3. Okay, that first step we did like week 1. So 10 plus 1 is 11. Keep variable, keep your exponent. And then this positive 1/3 equal, I didn't touch this either, got a 4/5. Now this, same exact numbers, different signs. Those are the ones that go to 0. Like I did that on purpose because I wanted that to go to 0, right? Now, if I look, I need to move this, right? Because this has an x variable and this doesn't. But y'all, what is that going to turn into? What's 11 over 11? Yeah, Trey, it's just 1. I just haven't rewritten it yet, but that's going to turn into just x, right? So I now have my one single x. I've got stuff going on around it though, so I need to get rid of it. And the way you quote unquote get rid of it is to do the inverse. So because it's a positive 1/3, what I need to do is subtract 1/3. Whatever you do to one side, you have to do to the other. Now, y'all, I'm not going to write 11 over 11x. I'm just going to go ahead. I know 11 divided by 11 is 1. So I have 1x. That's from my mess up right there. I have 1x. And then do y'all see here? Additive inverse. Exact same number, different signs, means it goes away. It cancels. So, and then I notice I have my equal sign, right? Excuse me. Right here. This is one of those not so fun, kind of annoying fraction problems because my denominators do not match. So I need to actually make them match. Does anybody know what the least common multiple is of 3 and 5? 15. That is correct. Now, Trey could have gotten that by just doing 5 times 3 or actually listing the multiples. 3, 6, 9, 12, 15. 5, 10, 15. Hey, first one I got 2, that's what I use, right? Now I'm making these equivalent fractions, which means whatever I did to the bottom, I have to do at the top. So what I get, y'all, is 12 over 15 and 5 over 15, right? Now let me replace these with these. My 4/5 became 12 over 15. My problem, the operation, is telling me to subtract this 1/3, but now it's 5 over 15. You could also see this as you're adding a negative 1/3, okay? That introduces a whole extra sign whenever you don't have to do that. Okay, now denominator's the same, good, I can keep. And then 12 minus 5, signs are different, so you would subtract, keep the sign of the larger, which is 12, which is positive, and I get 7/15. So my x, final answer, is 7 over 15. Y'all, I think there's about 10, 12-ish problems, and they increase in difficulty the same way we did them. That first little one step, maybe another little one step, maybe with different signs. And then, yeah, if you look at your notes today, you can solve every single problem. Oh, there's one more though. You can